Um, you know that incredibly distinct, earthy, fresh scent that hits the pavement right as a heavy rainstorm starts.
Oh yeah, everybody loves that smell.
Right, you take a deep breath, and it smells like life. People literally make candles trying to capture it.
Yeah.
But what are you actually smelling? Because, I mean, it isn't water. Water doesn't have a scent.
It definitely doesn't.
Yeah, you are actually smelling a molecule called geosmin.
And geosmin is fascinating, because of how it actually gets into your nose. It is produced by living bacteria in the dirt, primarily a type called Streptomyces. And during a dry spell, these bacteria are incredibly active, producing this molecule down in the soil. But it takes the rain to actually deliver it to you.
Because of the physics of the raindrop, right?
Exactly. When a raindrop hits porous, dry dirt, it basically flattens out and traps tiny microscopic air bubbles underneath it.
And those bubbles get pressurized by the water, so they rise up to the surface of the raindrop and burst, acting like this, like a natural microscopic perfume atomizer.
That's a great way to put it, yeah.
They just shoot tiny aerosols of this bacteria and the geosmin molecule straight up into the air.
It is this beautifully complex mechanical process. You are literally inhaling the aerosolized, waking, microscopic life of the soil.
Which is just wild to think about. And, that realization is really our mission today on this deep dive.
Yeah.
We want to completely change how you view the dirt beneath your feet.
Yeah, it's definitely not just dirt.
No, not at all. Because whether we are exploring modern soil microbiology or, the agricultural genius of ancient Egypt, or even the environmental codes of classical Islamic law, the prevailing truth is that the ground is not dead rock. It's the living, breathing skin of the earth.
Yeah, and we really cannot overstate the word living when talking about the skin. I mean, to give you a sense of the sheer density of life we are talking about here, if you step outside and scoop up a single teaspoon of healthy, fertile topsoil, just 1 teaspoon, you are holding more microscopic organisms than there are human beings on the entire planet.
Wait, really? A single teaspoon has billions of organisms.
Billions.
Yeah.
You pick up a pinch of dirt, and you are holding a population that is vastly larger than all of human civilization.
That is staggering.
It is this restless, massive workforce, bacteria, fungi, nematodes, arthropods, and they are constantly chemically breaking down dead organic matter. They're pulling nitrogen out of the atmosphere and fixing it into forms that plants can actually absorb. And they're aggressively protecting plant roots from pathogens. So it's this completely hidden, autonomous ecosystem that sustains absolutely everything living above it.
Okay, let's unpack this a bit, because moving from the sheer scale of life in the dirt to how deeply intertwined our own human biology is with this underground world, it's incredibly profound.
Oh, absolutely.
Like, let's look at the language used in the Quranic Perspective from Surah al-Mu'minun regarding human creation.
Yeah, the linguistic choices there are remarkably precise when you map them onto modern biology. The text states that humanity was created from a sulam and tin.
Right, and tin translates directly to clay or mud, referring to the earth.
Exactly. But sulala is the operating word here. It translates to an extract, like a highly refined essence or a very specific selection drawn out of a much larger, complex whole.
So human creation isn't described as like taking a clump of dirt and making a crude mud pie in the yard.
No, not at all.
It's described much more like a biological centrifuge. You take the raw, chaotic crust of the earth, spin it down, filter out all the inert noise, and pull out only the absolute most vital animated essence.
That is an excellent way to visualize it, because when we examine the chemical makeup of the human body, that centrifuge analogy just holds up perfectly.
How so?
Well, our cellular biology is built entirely on a backbone of carbon, and we are composed of about 65% oxygen, which is found abundantly in soil as various oxides. We are roughly 60% water, requiring massive amounts of hydrogen, another primary component of soil chemistry.
And then you have nitrogen, right, which is the foundational building block for all of our amino acids, which synthesize our proteins and build our muscles.
Exactly. And calcium, which forms the rigid mineral structure of our bones. I mean, think about it. Every single atom of calcium that is giving structure to your skeleton right now was, at some point, physically mined out of the dark, crushed rock of the earth by a plant root or a fungal thread.
Wow.
Yeah, before it made its way up the food chain and onto your plate. From a purely biological and chemical standpoint, you are quite literally an animated extraction of the planet's crust. You are wearing the Earth.
Man, it really makes you look at your own hands completely differently. But it's not just about what we are made of, right? It's about how this living Earth operates as a collective entity. Let's talk about the Wood Wide Web.
Oh, this is my favorite topic.
Because the mechanics of how this works sound almost like science fiction. I mean, I always used to picture trees as these isolated pillars just competing with each other for sunlight and water.
Most people do, but modern forestry and microbiology have revealed these massive underground fungal networks that connect entire ecosystems.
Right, they're made up of these microscopic threads called mycelium.
Yes, mycelium. And these threads don't just passively hang out near the trees. They actively seek out plant roots, and they physically weave themselves into the cellular walls of the roots.
So they're creating a direct biological bridge between the fungus and the tree.
Exactly. And through that physical bridge, they basically run an underground economy.
Because the trees use photosynthesis to create carbon-based sugars, which the fungi need.
Right, the underground fungi cannot make sugar themselves since they don't get sunlight. So the trees pump those sugars down into the mycelium. In exchange, the fungal network acts as a hyper-efficient, massive extension of the tree's root system.
Because the mycelium threads are vastly finer than tree roots.
Yeah, which means they can bore into microscopic crevices in rocks and soil to scavenge for water and vital minerals like phosphorus. Then they draw them back and deliver them directly into the tree's cells.
Here's where it gets really interesting, though, because it goes way beyond just a basic transaction of, like, sugar for phosphorus. There is an active system of mutual support.
There really is. This network radically shifts our understanding of nature away from being just this purely brutal zero-sum competition.
Yeah.
Researchers have actually mapped how older, massive, deeply established trees, they're often called mother trees, they will actually use this fungal network as a pipeline to pump vital nutrients and water to much younger, struggling saplings.
Saplings that are caught in the deep shade of the canopy and just can't get enough sunlight to photosynthesize energy on their own.
Exactly. They are actively subsidizing the younger generation to ensure the structural integrity of the entire forest community.
That's amazing. And they even use the network for defense, right?
Yes. If a tree on the edge of the forest is being attacked by, say, an infestation of aphids, it will send chemical warning signals down through its roots into the fungal network.
Which then transmits the signal to neighboring trees.
Exactly. Those trees receive the alert, and they preemptively begin pumping foul-tasting defensive chemicals into their own leaves before the insects even reach them.
That is just staggering. It's literally a subterranean internet of chemical data. And, all this complex architecture is maintained by creatures we barely even acknowledge. Like Charles Darwin, the guy who gave us the theory of evolution, traveled all over the world studying exotic species. He spent the last decades of his life obsessively studying the common earthworm.
Yeah, Darwin realized that the earthworm is the ultimate geological engineer.
Right?
He calculated that in a single acre of healthy land, you might have hundreds of thousands of earthworms. And their primary function is essentially as a mobile digestive engine.
They just eat dirt all day.
Basically, they consume decaying leaves and organic matter, they grind it up in their gizzards using tiny ingested stones, chemically alter it inside their gut, and excrete it as highly refined, nitrogen-rich topsoil.
Plus, their constant tunneling acts as this massive aeration system. So instead of rain hitting a hard, compacted surface and just washing away, the worm tunnels allow the water to deeply penetrate and store itself in the ground.
Yeah, Darwin essentially concluded that almost all the fertile topsoil on Earth has passed through the digestive tract of a worm at some point in history.
Okay, so if the soil is this massive, interconnected, self-healing organism that literally digests rock into life, how is it possible for human civilization to actually kill it? Because history is full of societies that seemingly committed agricultural suicide.
Well, it happens when a civilization begins treating the living skin of the earth as an inert mechanical factory floor.
Right.
When you strip away the biology and you treat it just as a medium to hold plants up while you pour synthetic chemicals on them, the ecosystem shatters.
The soil structure just collapses.
Exactly. Water can no longer be absorbed, which leads to catastrophic flooding, and that is immediately followed by severe drought because the ground just doesn't hold any moisture anymore.
Which brings us to the Dust Bowl in the United States during the 1930s. That's a prime example of this mechanism failing spectacularly.
It is the ultimate modern cautionary tale, because the Great Plains were originally covered in these native perennial grasses, and the roots of these grasses went incredibly deep, sometimes 10 to 15 feet down.
Wow.
That dense root matrix acted like biological rebar, holding the soil structure tightly together even through years of intense drought.
But then, aggressive, mechanized farming moved in. Tractors ripped up all that native grass, destroying the deep root systems, just so they could plant shallow-rooted cash crops like wheat.
Right, and they left the delicate topsoil completely exposed, so when the inevitable dry cycles returned, the cash crops died. And without that biological rebar holding the earth together, the soil completely lost its structure.
It just desiccated into fine powder.
Yeah. When the high winds swept across the plains, they picked up millions of tons of this powdered topsoil. The ground literally blew away. Giant, suffocating black blizzards of dust darkened the skies all the way to Washington, D.C.
It triggered a total economic collapse and mass starvation across the region. Because it wasn't a failure of farming technology, it was a fundamental failure to understand soil biology.
Exactly. And, you know, it's not just a modern industrialized mistake. Let's look at ancient Mesopotamia.
The cradle of civilization, the birthplace of agriculture.
Right, but they fell victim to a much slower, quieter collapse driven by their irrigation practices.
Also,
Well, Mesopotamia relied heavily on complex irrigation canals to bring river water to their crops in an arid environment, which seems completely logical. The problem was they didn't implement proper drainage systems to get the water back out.
wait, let me push back on this for a second, because I water my houseplants with tap water every single week and they don't turn toxic. How does fresh, natural river water poison a massive agricultural empire?
Okay, think about your houseplant. The pot has a hole in the bottom, right? When you water it, the excess drains out into the saucer, which flushes the soil. Mesopotamia had no saucer. Every source of fresh water, even a pristine river, contains tiny, trace amounts of dissolved salts and minerals picked up from rock.
Oh, I see.
The Mesopotamians would flood a field and just let the water sit there and bake in the harsh sun.
Ah, so the water evaporates, but the salt doesn't.
Exactly. The pure H2O evaporates into the atmosphere, leaving those microscopic trace salts locked in the dirt. Over a few years, it's harmless. But over generations of constant flooding and evaporating with zero drainage, the salt accumulation becomes massive.
So eventually the soil becomes totally toxic to plant life.
Yes. The incredibly fertile crescent that birthed human empires slowly became a barren, white-crested wasteland of salt.
Man. So what does this all mean for us? Are we just doomed to be a parasite that eventually eats its own host until it dies? Did anyone in antiquity actually get this right, or is civilizational collapse just inevitable?
It is not inevitable. Ancient Egypt actually stands out as perhaps the first truly sustainable agricultural economy in recorded history. I mean, it lasted for millennia.
Usually the narrative you hear is just, the Nile flooded every year, deposited some magic silt, and the Egyptians had it easy.
Yeah, and that narrative completely ignores their engineering and ecological brilliance.
Yeah.
They actually migrated to and settled the Nile as a desperate adaptation to severe climate change.
Wait, really?
Yeah. The surrounding region, which is now the hyper-arid Sahara Desert, used to be a green, thriving savanna. But a massive climatological shift caused rapid desertification. The environment dried up.
So instead of collapsing, the population moved to the river valley.
Exactly. And they learned to master the soil to survive in a much harsher world. They didn't just passively let the river flood, they actively manipulated the ecosystem.
Right, they used the shadoof, didn't they?
Yes, the shadoof is this hand-operated counterweight lever system used to lift buckets of water from the river into a highly engineered elevated canal network.
Which allowed them to distribute exactly the amount of water needed directly to the roots.
Precisely. It prevented the standing water evaporation that completely doomed Mesopotamia. They also practiced strict crop rotation to balance nutrient draw.
And they utilized raw solar energy, right?
Yeah.
Laying clear covers over wet soil to literally steam and sterilize it with the sun's heat.
Yeah, it killed harmful nematodes without using any chemicals.
So they adapted to climate change by becoming master stewards of the carbon cycle, which actually connects to a modern environmental reality that completely shocked me when I read it. Preserving soil isn't just about ensuring we have food to eat. It is literally one of our most potent weapons against modern climate change.
Oh, absolutely. Because of the carbon sink mechanism, global soils hold more carbon than the entire atmosphere and all the plant life on Earth combined.
Wait, hold on. More than the entire atmosphere, A&D, every single tree in every forest on the planet.
Combined, yes.
That is insane.
It is. When plants photosynthesize, they take carbon dioxide out of the air, but they don't just use it to build leaves and branches. They actually pump a massive portion of that carbon down through their roots as liquid exudates to feed the fungal networks we talked about earlier.
And the fungi then lock that carbon deep within the mineral structure of the soil.
Exactly. It is a massive planetary vault. But when we degrade the land, when we till it aggressively and destroy those fungal networks, that vault breaks open, and centuries of stored carbon oxidize and escape right back into the atmosphere.
Wow, okay, so we have the biology of the soil, we have the history of how ignoring it causes catastrophic collapse, and we have the blueprint of sustainable success from Egypt. But the question becomes, how do we actually legally and ethically incentivize human beings to protect and revive this vital resource today?
Because knowing the science is one thing, but human societies run on rules and incentives.
Right. And this is where classical Islamic jurisprudence offers this brilliantly pragmatic legal framework. It centers around a legal concept called al-Mowatt,
which literally translates to reviving dead land.
Yeah. The premise essentially states that if a person finds barren, unowned, dead land far from civilization, and they manage to bring it back to life, they are legally granted ownership of that land.
It's a huge incentive.
It is, but let's be real here. Doesn't ancient law like that actually scale to a modern world? I mean, a massive corporation today could easily afford to just throw money at a piece of desert, put a fence around it, and claim it just to hoard the real estate. How did they define actual revival so it wasn't just a giant corporate loophole?
Well, the classical jurists anticipated exactly that kind of exploitation, merely putting up a fence, or digging a shallow, useless trench, or throwing some rocks around a perimeter that does not grant you title to the land.
Okay, so what is that considered?
That is merely called tajir, which just means reserving the right to attempt a revival. It gives you temporary priority, nothing more. To actually earn the title, the revival must be fundamentally ecological and productive.
So you have to actually alter the biology of the space.
Precisely. If the land is dead because it's dry, you have to dig a well, hit a sustainable aquifer, and establish actual irrigation. If the land is dead because it's a stagnant, flooded swamp, you have to engineer a drainage system to make it arable.
You have to successfully plant trees that take root or cultivate crops that yield.
Right. The standard is always actual, measurable ecological restoration.
And there is a strict time limit to prevent hoarding, too. The second caliph, Umar bin al-Khattab, established a 3-year rule.
Yes.
If you stake a claim on a piece of dead land, you have exactly 3 years to bring it to life. And if you fail, the state strips your claim and hands the land to someone who actually has the capacity to do the work.
It is effectively an ancient biological anti-monopoly law. You cannot hoard the earth for speculation. You use it to generate life or you lose it.
Which completely short-circuits land speculation.
Yeah.
And the application of this law actually sparked a fascinating debate among classical scholars regarding the role of government versus the individual in environmentalism.
And a debate that is incredibly relevant today, yeah.
You're talking about the debate between Imam Abu Hanifa and Imam Shafi.
Right. So Imam Abu Hanifa argued that reviving dead land requires explicit prior permission from the state. His legal reasoning prioritizes systemic organization.
So the government needs to survey the land, ensure it doesn't interfere with future public infrastructure, prevent disputes.
Exactly, and ensure the revival fits a broader state-managed environmental plan.
It's very much a top-down, centralized regulatory approach, kind of like how we view the EPA or federal land management today. But Imam Shafi and others like Imam Ahmad bin Hanbal looked at it completely differently.
They took a fundamentally decentralized grassroots approach. They argued that the religious and societal imperative to green the earth is so universally vital that an individual does not need state permission to go out into the distant wilderness and revive land.
Because the sheer moral weight of bringing life back to the soil acts as its own ultimate justification.
Exactly. You don't wait for bureaucracy to heal the planet, you just go out and do it.
It's such an amazing philosophical split. Do we need massive government grants and zoning laws to save the environment, or should individuals just start guerrilla gardening abandoned lots and planting food forests on their own initiative?
And despite their differences on how to initiate it, all of these scholars universally agreed on an absolute limit to privatization.
Right, there are certain natural resources that can never, under any circumstances, be monopolized or owned, whether by an individual or the state.
The public rights: water, fire, and pasture.
Correct, and fire in this classical context refers to combustible fuel, like wood from wild forests, and pasture means the natural grazing grasses required for livestock.
Because these are the absolute baseline requirements for human survival. A society instantly breaks down if one entity owns the entire river or all the grazing land and charges a toll for access.
These must remain shared public commons. It is deeply rooted in the Quranic principle of mizan, or balance. The ecosystem must remain in equilibrium.
Right. You are permitted to own the specific farm you revived through your hard labor, but you cannot hoard the river that feeds the entire valley.
So we've covered the microscopic biology, the historical collapse of empires, and the complex legal frameworks used to manage the earth. But where this all culminates is actually deeply personal.
It really is.
Because the ultimate incentive structure here isn't just legal, it's spiritual.
Law organizes society, but spirit drives human action. In the Islamic tradition, the Prophet Muhammad established a profound generational mindset regarding the environment. He taught that if a person plants a tree or sows a seed, and subsequently any bird, any animal, or any human being eats from it, that act is eternally recorded as an ongoing charity for the person who planted it.
Wow, so you plant a fig tree. 50 years after you've passed away, a bird eats a fig from your tree. You are still receiving spiritual credit for sustaining the ecosystem.
Exactly. It permanently anchors your personal legacy to the biological health of the living world. You aren't planting for your own harvest, you are planting for a future you will never see.
And there is one specific hadith, a recorded saying of the Prophet, that just perfectly illustrates the sheer, uncompromising power of this obligation. It says, if the final hour comes while one of you has a palm shoot in his hand, let him plant it.
The final hour. The apocalypse. The end of the world is actively happening.
The sky is falling. There is no tomorrow. There is no future generation to harvest the dates. The action is entirely futile from a practical economic standpoint.
And the instruction is still put the seed in the ground.
Plant the tree.
Because your responsibility to the earth, your duty to be an active steward of the soil, is not contingent on the outcome. It is an inherent moral obligation to life itself.
Even in the face of total, inescapable destruction, your ultimate duty is to facilitate creation. The profound optimism in that is just overwhelming to me.
It is the ultimate rejection of nihilism. You don't surrender to despair just because the climate looks bleak. You put your hands in the dirt and you plant the shoot.
I want to leave you, our listener, with a final thought to mull over, kind of tying all these threads together today. If our biology is fundamentally chemically an extract of the soil, and the soil itself isn't dead, but acts as this massive, communicating living organism that shares nutrients, defends itself, and digests rock into life.
The living skin of the earth.
Exactly. When we carelessly pave over massive stretches of incredibly fertile land with millions of tons of impermeable concrete, when we completely seal it off from the rain, the air, and the mycelium networks, are we just building a parking lot? Or are we actually suffocating a part of our own extended biological family?
It's definitely something to think about.
Thank you for joining us on this deep dive. Tomorrow, when you walk outside, I hope you look down at the dirt just a little bit differently. And the next time it rains, take a deep breath. Smell that geosmin.
Because that is the smell of billions of tiny organisms waking up to do their job.
The very foundation of human civilization. We'll see you next time.